Hello, in this video I'm going to be working through some simple trig equations, and this actually follows on really nicely from my previous video which looked at how to solve them. So if you haven't seen that, it might be worth going back, watching that video, then coming and having a go at these questions because they're ever so slightly different. If this video is useful, please do go over to my channel where I have loads of other maths tutorials, and you can also check out my website which I'll have linked in the video description. Okay, so let's look at this first question where we're asked to solve 2 sine of x equals -2 between 0 and 360 degrees. Now, whenever we're solving a trig equation, it's always good to make the coefficient of our trig function 1. Basically, make the equation read sine of x equals, cos of x equals, or tan of x equals. And so to sort this out, the first thing I'm going to do is divide both sides by 2. Because by doing this, now I have sine of x equals, well, -2 divided by 2 is -1. And now I've got sine of x as the subject, I can now go ahead and solve it. So the first thing we're going to do is draw a rough sketch of this graph, and it really doesn't have to be perfect. I just always like to have a rough sketch. So there's sine of x, so there's 360, there's 90, 180 and 270. Okay. Now actually, just by looking at this graph or sketch I've done, I could probably solve this equation, but we'll solve it as we would with any other. So from here I'm now going to do inverse sine of -1, and that tells me that x is going to equal, well, inverse sine of -1. You can do this on your calculator if you like, but I know that this is going to be x equals 270 degrees. So let's zoom in and mark on this solution we found. So I know it equals -1 at this point here, 270. Now, I know now that there's only going to be one solution, but let's say we didn't know. How could we solve this? Well, let's think about the symmetry. Between 180 and 360, the graph is symmetrical about this point here, 270 degrees. So to get to 270, I've gone 90 degrees to the right of 180, haven't I, to get to my solution? And so if I go to 360 and I go back 90 degrees, that's going to take me to another solution on the curve. And in fact, that other solution is the same one. It's 270 in this example. And so we're done. That's that question solved. We know that x equals 270 is the solution. And you can always go back and substitute x equals 270 into the original equation on the left-hand side and show that it equals the right, and just check you've got it right. Let's now look at the second question, where we've been asked to solve where cos of x equals √2/2 between 400 and 540 degrees. So that's quite an interesting interval, and it maybe looks a bit tricky, but for now we're just going to completely ignore the interval and just solve the problem as you would if it was 0 to 360 or something quite nice. So the first thing I'm going to do, like always, is draw a rough sketch of cos of x, just to help me see and visualize what I'm trying to do. So here's my rough sketch of cos x. I'm going to label on some key points. I've got 90, 180, 270 and 360. Next, I'm going to do inverse cos of √2/2, and that would tell me that x equals the inverse cosine of √2/2. And if I type this into my calculator, it tells me that there's a solution at x equals 45 degrees. And so what I can do is zoom into my graph, and I can mark on that solution here. So here's x equals 45 degrees. Now remember, the graph of cos of x is symmetrical between 0 and 360 degrees at the point when x equals 180. So if I've gone 45 degrees to the right of the origin to get to my first solution, well, if I go to 360 and I go back 45 degrees, that's going to take me to my other solution here. And in this case, well, 360 minus 45 is 315 degrees. And so that tells me I've got another solution to this equation when x equals 315 degrees. Now, annoyingly, neither of these solutions are actually in the interval I'm interested in. However, it doesn't mean that these solutions are useless. In fact, they're going to be really helpful in finding the solutions that I want. So now we've found the 2 solutions in this initial first period between 0 and 360, I'm just going to add or subtract the period of the graph from both of them to jump me to the other solutions. So if I'm at x equals 45 and I add on 360 degrees, that's going to take me to another point on the graph where it equals √2/2. And so 45 plus 360 is 405 degrees. And again, if I extend my drawing of cos of x like this, you can see if I add 360 on, it's taken me to this solution over here at 405, which is in my valid ranges that I can have for x. Now, if I add 360 on to 405 again, just to check, you can see I get x equals 765 degrees, which is outside my range of solutions. And so you can kind of tell now, if I keep adding on 360 degrees, it's just going to get further and further away from my range. So I can stop now, and I know this is my solution that I want, and actually I can cross these two out and reject them because they're not useful, they're not valid. Let's just check with 315, although I already know it's not going to be in the interval. If I add 360 onto it, I get x equals 675. And actually neither of these solutions are valid, so I can cross them both out. And in fact, cos of x only has one solution in this interval where it equals root 2 over 2, and it's when x equals 405 degrees. Let's now move on to the final example, where we're asked to solve 2 tan of x minus 1 equals 0 between 0 and 360. Remember what we said earlier, we want to make tan of x the subject. So the first thing I'm going to do is add 1 to both sides, and I get 2 tan of x equals 1. And I want the coefficient of tan to be 1, so I'm going to divide both sides by 2. And I get tan of x equals 1/2. Like before, I'm going to draw a rough sketch of this function just to give me an idea of what it is I'm trying to find. So let me make this look a bit nicer. There we go. So I know that it's got this asymptote at 90 degrees, and then it's going to have another one at 270, and then it stops here at 360. So where does this graph equal a half? Well, I'm going to do inverse tan of 1/2, and when I do this, let's type it in our calculator, inverse tan of 0.5, that tells me that x equals 26. Let's do 0.57, let's do it to 2 decimal places. Okay, so x is 26.57 degrees, and I could mark that on, that's going to be this point here. Now if you think back to the last video, with tan there was only ever one solution within each period. So now I've done that, all I need to do is add or subtract the period of tan to this solution to find the others. And for tan, the period was 180 degrees. So to this solution, I'm going to add on 180, and that gives me another solution at x equals 206.57 degrees. And again, let's add on 180 again, and you can see this is now going to be outside the range I'm interested in. It's going to give me 386.57 degrees, which is too big. It's not in the interval I'm interested in, so I can just reject that. I can cross it out, and you can see we get 2 solutions for where 2 tan of x minus 1 equals 0, one at x equals 26.57, and another at x equals 206.57. So hopefully this video was useful. If it was, do go over to my channel where I have loads of other maths tutorials, and I'll also link my website in the video description, so you can go over there and see all of my videos in a much more organized place where it's easier to find what you want. Thanks for watching.